Okay, we're recording. Go ahead.
My presentation is about it's called Beyond Climate Change because I'm sure everyone has ad nauseum heard about climate change and it's so bad and everybody's like going to pot. But what happens after the climate change actually hits and the planet changes and stuff happens, right? So nobody is actually talking about.
Because I'm not sure how I was catching that.
I can't talk louder.
Okay, so it's
difficult. Okay. Okay. So pretty much the first slide is for Lasika, who is a climate change denier. So I have to. Yeah. What? He told me, right? That he does not believe the global warming is happening. So yeah, basically, it takes, like in the last 5,000 years, what they've managed to calculate is that the planet's warm by 7 degrees. But since they started monitoring weather from like 1880 onwards, in the last century, it's gone up 0.74 degrees. So what it took like 5,000 years to get 7 degrees hotter, and in the last 100 years, you've got almost a degree hotter, which is like 10 times the rate of. So Lasita, unless you can explain that another way, like global warming is happening.
You're using a pseudoscience, it's not real science.
Yes, well, whatever. But then the problem that lots of people have with global warming is like, you think, wow, everything's going to be hot. But 2010, 2011 and 2012 were called the big freeze because they were the coldest years on the planet since 1880 when they actually started like measuring temperatures. So every climate change denier is like, it's getting colder, what do you mean it's getting hotter? That's bullshit, right? But then you have temperatures like Pakistan hit the record in 2010. So it was the coldest year on record, and Pakistan had the highest temperature ever recorded on Earth since 1880, which was 128.3 degrees Fahrenheit.
What's that in Celsius?
In Celsius, it's 53.5.
Wow.
Like photosynthesis shuts down at 95 degrees Fahrenheit.
Celsius.
What are you? Stop being like a
British.
Yeah, exactly. British. Right?
No, that's like the rest of the world.
But yeah, at 98 degrees, photosynthesis shuts down. At 104, most plants die. So this was 128. Eastern Europe has the same thing, like crazy temperatures. 2011, Asia hit like 120. North America had like 30 degrees Celsius weather, which was very like cold. So anyway, it was like Asia in 2014 was like the hottest year on record. So you have the coldest year on record, hottest year on record, and then if that wasn't enough, 2014's winter, like Washington DC, had its coldest year ever in 130 years. So there's a bit of a paradox about that, so that's why people are all like, I don't know whether global warming is happening or not.
There was snow in Egypt also. Like
pretty much. And okay, this was where people sometimes confuse the fact that the greenhouse effect is bad, blah blah blah. But everyone knows the greenhouse effect works, right? I'm assuming you do know. So I'm not going to go into that because my presentation is basically it's based on one area which people are now starting to pay a lot of attention to but never did before. Climate change, like the effect of the sea on climate change and how that is like drastically going to affect pretty much human beings everywhere. And we should be preparing for that and doing something about it, and there is minimal work that has been done to take any precautions for it. The only thing that's relevant here is that sun shines down, heat is absorbed by the earth, which is what actually allows us to live on this planet and things to grow, but the ice caps in the sea acts as a sunblock because it bounces stuff back so that we don't absorb all the sun, which is then would make us fry. And a funny little graphics which nobody can actually see. So what I said, the climate change, it's only now as this like big machine on climate change. There's one scientist going, I found a button that does oceans! Because basically that's what I'm going to talk about. Right? And they've just discovered that in the last 3 or 4 years is when they've started talking about the role of the ocean in actual climate change. And the ocean plays a huge role. This is what we call the global conveyor belt. It is responsible for everything from the health, it's basically responsible for the health of planet. Right? How this works is, obviously, you know the principle where like colder, denser stuff sinks to the bottom, warmer, like less dense stuff sinks to the top. Right? So what happens is that when the ice melts, you have cold water, which obviously is the bottom, and there is this whole array of currents which goes right from the globe, taking this cold water all the way from here, taking it down there, and what happens is after a period, it wells up. There's a process called upwelling, where because it gradually, slowly gets warmer when it moves into temperate regions, it moves to the top. And there is a process by which it's called upwelling and downwelling, where then whatever is at the top, which has absorbed oxygen and stuff like that, because this water, that water switch, they basically switch. And that is how like the deep ocean gets all its oxygen and stuff like that, where plankton and krill and stuff grow. And that's why creatures can survive in the deep, because of that entire like system. Now, if you need to know the volume of this is about 165,000 cubic kilometers of water. It's 100 times the annual output of the Amazon. And that volume of water moves like an inch a day. So this whole process would take like 100 years. Funnily enough, you probably now, if you swim in the water, we're swimming in the same water that like Columbus sailed across 300 years ago. Wow. By the time it comes here, because he sailed across here, and it took a couple of 100 years to get to here. And now you're swimming in the same water. But why it's important is this: thermohaline like circulation. Thermohaline, heat and salt. The salt in the water makes it dense, which contrasted to the mass that it right now inhibits. If the water becomes less dense, it spreads. And generally the warmer water, because spreads up. But because there is such a big bulk of like colder water holding it down, you don't have like ocean spreading. You don't have the water spreading further inland than it already is. The issue is that if you have this the thermohaline, and it's also the warm, because 90% of the ocean, like 90% of the world's water is in the ocean, and evaporation, precipitation, all that depends on water evaporating from here, not so much from like anywhere else. So the warm water rises to the top, gets evaporated, and you have that nice social studies thing we did where the wind takes the water vapor a certain time, and then it all clogs together. It gets too heavy and it falls to the ground in the form of rain or in the form of snow. This evaporation that happens along the red band of the conveyor belt also drives trade winds and everything, because when there is evaporation and also there is heat, the thing is that displacement, cold air and warm air as well. So the thing is that evaporation itself, because the evaporation happens more along here, because it's warmer water at the top, so more evaporation, more precipitation, also means that there is a wind that goes through, which is actually the trade wind. The trade wind is created because of this whole system. And you have like little subsystems because of the Earth's rotation, and that form currents here in various places. There are like 5 major gyres. Those drive basically ocean commerce, like all the big ocean liners, everything, like they take those particular routes, and those are dictated because of the way that this conveyor belt runs. So basically all the precipitation you get around the globe is dictated by this. For instance, if you have the world getting hotter and you get a faster rate of evaporation, you have more, like it speeds up because more water is being evaporated. So the thing is, this conveyor belt has to make the adjustment for the cold and the heat. It works like the same, like how your respiratory system works when you're sweating. How like heat and it adjusts. This is basically the respiratory system of the ocean, of the globe. Right? So if the moment that evaporation starts happening, like the planet starts heating, there is more evaporation, more precipitation, which means that this has to work overtime to cool this area, because that has to work faster to make sure that it cools. And at some point, it gets too hot, and then what happens is that the upwelling starts happening earlier and earlier and earlier on this system. And what happens is when it hits here, because of the temperatures here, in this area, it cools, and salt doesn't sink to the bottom. It's only salt doesn't evaporate, so it sinks to the bottom and creates density, right? Which chills again. But the thing is that if you start, this process starts say from here, and it starts getting hotter all the way down here. Again here too, you're going to have like less water that's evaporating, which means you have more ice in this area. That's how the paradox of like your global warming causes ice age, because there is not enough water here then to form. Like there's not enough. There's too much lighter water and heavier water. The thing is, it forms ice. So that's the it does. Right? So the thing is that it's like a pH balance, the haline, the salt balance of the water, because these ice caps, like the glaciers, Greenland has about, it's calculated that if Greenland's ice melts, and that's all pure water, it will add 20 meters to your current sea level. It has that much water in it. And if like the ice caps melt, like the polar ice caps, you have like 100+ meters of water. And it's not only the water that's going in, it's pure water going in, so your salt water gets diluted, which means that the heating process, because this you don't get the deep cold current, you'll have more sort of desalinated water, which means evaporation will happen at a bigger rate, which means more evaporation means more precipitation. More precipitation, more evaporation from everywhere means that your entire wind current system around the globe will change. Because colder temperatures, warmer temperatures trying to like compensate for each other. Which means you throw all your like shipping routes and stuff out of whack. Potentially storms and stuff will become more, because what happens is if there's more warm air and cool air has to compensate. If it's like the fan basically. This level of stuff, because it's this warm, is okay. But if it gets a couple of degrees warm and you're sweating, you have to speed it up to a... So if wind speeds up, what happens is, if the precipitation goes up and you have cloud formation, and there is an X amount of wind speed that is generally the norm, it pushes the cloud formation, say, over here. By which is the time it like optimizes and it cannot hold anymore, it precipitates into rain. So you have a nice clean rain here. What happens if the precipitation happens faster? Winds grow stronger, and then either the evaporation becomes too much to hold and the winds can't push it all the way to where it normally got pushed, so it will precipitate earlier. Or, depending on the pressure, it would precipitate later. So what would happen is, what is now a nice green area could potentially not get any rain. Places that are now dry could get rain, you could just rain over the sea because the water is far too heavy to like carry any further. Right? But what's going to happen is that throws all your agricultural systems up and whack. Because right now, all of us, especially in Asia, depend on monsoons for our agriculture. And that's why we're seeing problems now with no rain coming when it's supposed to come, and then in the Samarasinha there's drought when there's supposed to be a harvest. So, this global conveyor belt is incredibly important, and that's why people are yelling about 2 or 3 degrees of temperature rise being dangerous. So they don't really talk about this, because this will affect like your winds, it affects the currents, it affects rain patterns, weather patterns right around the globe. That's just a thinking over it. Right, so if this gets disrupted, which it is getting now because it's hotter, apparently in El Nino weather like events, coral dies because the sea gets so hot. Right? And the last time that happened was like in the Permian. The seas got really hot. Things died. It's also intriguing, like this global conveyor belt, I just realized it's so awesome because if you look at all these areas where they are upwelling here from cool water to warm water, it brings all the nutrients up from the colder water up into the warmer water. All your best whale watching spots are here, 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 here. Because all those guys come to the top, and so that's why they're saying like ocean habitats are being depleted and stuff like that, is because it's being disrupted. The food is no longer appearing at the time and stays it should. So, what happens next? So, the global conveyor belt has been disrupted. It will continue to be disrupted because no one's doing anything about the whole climate change issue. Everyone's facilitating and promising to do stuff and not actually following through. You all remember the movie Day After Tomorrow, huge waves and the icebergs, the sea levels raised, there was flooding, people were, ice age suddenly appeared, whatever it is, right? So, in the last century alone, sea levels have risen 8 inches. And that is, they say, simply because of the density displacement problem in the thermohaline. More heat, less salinity, and because of the melting water, and it's also because of flooding. Rains bring like desalinated water, and all the water ends up somehow going on rivers or waterways into the sea, desalinating the sea, so that you are slowly like reducing the amount of the density of the ocean, which means it spreads. So right now, 8 inches it has risen just in the last 100 years. 55% of the Netherlands is anyway below the sea level. And there are places in Europe, US, Maldives, all these places which are currently, like at current stands, anyway below sea level. And going by the current heat and temperature rise and the rise of the sea and stuff like that, they estimate that at the most conservative estimate by the turn of the next century, there will be 16 inches in the sea levels, or at the worst case, there will be 56 inches in the sea levels, which is about a fair amount, right? It's about almost 6 feet. So, yeah, Kiribati, the Salon Islands, all of them are suffering from that now. But this is Kiribati. All this, 10 years ago, is land. And this is just the sea slowly coming into the land. This is North Carolina, I think it's small, so you can't really see it. These are all tree stumps. Because this was actually land, and now it's become shoreline. So, ramifications of having rising seas. You have people think that there will be more Katrina-style events, but that is not necessarily the case. But there will be more storms, and the intensity of the storms will be more, and they will be longer. And we've already seen that. Like, lots of places saying it's unprecedented, we've had like 16 storms already in the summer. There will be floods. Because again, with the precipitation moving, there will be far more flooding. And conversely, there will also be more drought. Because in places which used to get water, like our Samarasinha, doesn't get it anymore. Or doesn't get enough of it. And that leads to the other big problem, climate refugees, which everybody's saying, oh my god, the whales, and oh my god, the little fishies and the birds. But what about the people? If the Samarasinha continues like that, there is no arable farming land in that area. What are those people going to do? Either they will have to move to places which are arable, which will create other problems with people going, oh, you're coming into my land, what is this? Right? Or what? There has to be something that they can do, but they will in effect be climate refugees. And that will precipitate economic crisis. Because if what you are depending now as your rice bowl is going to be dry, your people will have nothing to eat, but if you depend on those for imports and as your countries export, what are you going to do? Right? So those are questions that I think by now it's too late to say, oh, we should look at reducing carbon emissions. Everybody's talking about that, and people aren't doing it. They've been talking about it for 25 years now. So I think now we have to move beyond that of okay, we're trying to get people to reduce their emissions, but we also have to start thinking about what's going to happen in the next 50 or 60 years, because people aren't suddenly going to wake up tomorrow and say, okay, I'm going to stop.
Last year they did a report and they said that it's reached the point of no return.
Yeah.
It's reached a point where even tomorrow, if everybody stops and implements all these things, there will be a 60-year ongoing kickback effect from what we do today if you zero your carbon emissions tomorrow.
Nobody has any contingency plans for this.
That's what it's scary that there are so few contingency plans. Everyone's still talking about greening the planet and cutting down the carbon emissions, right? So, this is a picture. I'll try to make it large. This is, you can see, it's Scotland. There's this like promenade and a building and stuff, and this is the sea. Okay, it's really like that. That's Florida. It's like waves coming into. That's Connecticut. There's a house up there, and this is the sea. Now, the irony is that everybody thinks, oh my God, these are like Hurricane Sandy, Hurricane Katrina, this is awful. It's not. It's a general. This is what generally happens during a storm. This is a storm surge that hits you. This is not Katrina or anything. This is water coming over the levees during a storm surge because the wind and the waves are so high and the wind is so strong. Right. This is last year's pictures from like some generic storm. This 3 months of the year in Scotland. This is a place called something coats.
Red coat.
Not red coats, but something close to that.
Pretty bad.
But yeah, so in 3 months of the year, this is what happens. This is a nice promenade. I will show you what this beach looks like when it's not stormy. Okay, where is that? Oh, I don't have it. Sorry. But this is Blackpool. Okay, so you have Florida. Levees are obviously useless. Connecticut. This used to be a barrier island, this whole area. And barrier islands are very, very like necessary to stop the whole effect of the ocean and the waves like hitting like mainland. But over 10 years, this barrier island disappeared. In 2010, this was a picture taken in 2010 of like the waves just coming right over the island, and this was the last house standing, and in 2010 this collapsed into the sea as well. So now there is nothing to stop the waves just completely hitting the New England shoreline. This was a really big barrier island. This is Jakarta during a normal rainy day. It looks like Tumbula. It's not like the storm of the century or something. Normal rain. That's Thailand. Normal rain. This is Bangladesh. Normal rain in the cities. Right? That's normal. That is a normal Bangladeshi city. Which is slightly more severe than Tumbula.
So it's Venice with cholera.
Huh?
Venice with cholera.
Pretty much.
Yeah.
Right? So right now where weather patterns stand, these are all pictures from 2014 from like newspapers which had like storm, rain. This is Blackpool. Now these are storm surges and rain, flooding due to rain. This is Blackpool when the tide is out. We have a nice little promenade to talk about the steps. This is Blackpool when the tide is in. This happens every day. Right? The sea comes in almost a kilometer. This is Blackpool during a storm. That promenade you saw, which was about 50 feet high, the waves come right over that and wash over onto the road. During normal rainy season, not unprecedented storm event. Right? I have a fantastic video. If you want, I can show you like 2 minutes of a clip of the actual storm surge in Blackpool, if you want to see it or not. Huh?
Yeah.
Good, yeah.
What, you want to see the thing?
Go ahead.
Yes.
Or you can put it on maybe when you're changing post session, maybe after presentation while people are changing.
Yeah. So this is the one study I could find which has actually looked at populations which are exposed to coastal flooding, as Kolkata, Mumbai, Dhaka, Guangzhou, Ho Chi Minh, Shanghai, Bangkok, and Miami, Rangoon. It was like the top 10. And right now, by 2005, when the study was done, it was estimated that there were about 21 million people who were affected by those storm surges and tide surges, right? This is Satyavala Island, which is Sulabans, which was all paddy land. until the tide. And the sea came in. And the tide, and now this is permanently underwater. The Sundarbans are all going underwater now. Like, and there's 70,000 people live in this area, and they all have to like shift off somewhere. So yeah, so 21 million people just in these cities alone will be affected, and by 2017 that triples given our population rate in Asia. So that brings it to almost 100 million people who will be directly affected. The assets exposed to coastal flooding, because 60% of all major cities are on the coast or on major estuaries and rivers. So on those top 10 villages, top 10 towns and city areas subjected to flooding, the cost in billions of dollars in 2005 was estimated that it's about it's about $900 billion a year in 2005. They estimate that with the population and those cities' current development plans for their cities, by 2070, that will also triple. So it will be like 900 billion into 3, whatever that number is. I can't
$0.7 trillion.
Trillion, or whatever.
0.7 trillion.
Whatever, trillion. Right? Is the amount of damage that it will do. Right? So you would think that after these calculations come out, they would be making their first priority a way of like, how do I keep my population and my economy fairly safe? But nobody seems to be doing that. Right? See, okay, the current solutions that are around, right, from people who have actually implemented it, this is a huge, it's a half a kilometer wide barrier in Rotterdam. And it actually guards the Rotterdam port against storm surges. This, you can't see that actually, it's pivotal gates. The gates pivot shut like this and stop storm surges from coming in. It's a 20-foot high gate, and the waves come over that sometimes. Already, it cost $4 billion in like 2004 or something to build.
That protects the whole city.
It protects that whole, yes, because Rotterdam Port leads into the city, so it protects that whole area from surges. It will not, this is a problem, it will not protect it from floods, but it protects it from the sea coming in.
Just the sea coming in?
Yes, and that cost $4 billion in 2005. So I don't know how much that will be in current cost. These are the oldest, these are the Delta works, because the Netherlands is already thinking they were the first people to build the Delta works. The Delta works at, I think in 1998 or something like that, cost $4 billion. Pounds or euros, euros now. Right? $4 billion, the Delta works. And there's a fantastic, the Delta works are just barriers and a series of locks and barriers right across the sea, the estuaries, right across. They protect the Netherlands from like encroaching sea. And if you can see pictures there are on the internet, tons of them, it's like disaster prone. On a sea sturge, the water comes all the way up there. This is like the ship. That's the Delta works, water comes over that now in a storm. So they're saying in the next 40 years, this stuff will be inadequate. This is 4.2 billion plus another 400 million for other river guards. This is the Thames estuary barrier. They are currently saying, the Guardian has it on record saying, in the next 40 years this is not going to be enough to stop the sea from coming in. So all these people know this, it's like out there. Right? China is building across the Three Gorges Dam. That is supposed to be completed next year, $25 billion. Right? It's still not going to help them because that's just their 3 main areas. Everywhere you have an estuary, you have the problem of sea level rise.
That's like 15 Colombo ports.
Yes. So this is one of the ways of people, one of the ways of protecting you against sea level rise. The disadvantages are obviously it's pretty expensive. How many countries in Asia are going to afford this? And every country in Asia has problems with, like, they all have rivers and estuaries going to the sea, they all have massive coastlines. So unless you can come up with like 25, 48, I don't know, $100 billion, this option is probably not going to work for you. And it's the efficacy, because it will stop the sea from coming in.